Hello friends, welcome to Prismatic online class. In this class, we are going to look at the question on the board where they say, given that Z1 is equals to R1 into cos theta plus I sin theta 1 and Z2 equals to R2 into cos theta 2 plus I sin theta 2. Prove that Z1 is Z equals to Z1 over Z2. This is a conjugate of what? This is a what? A division of what? Complex number under polar form of what? Complex number. This is a polar form, but we are going to prove that polar form or trigonometric forms of complex number. How do we do that? Let's start. Prove. Okay. Z is equals to, we have R1 into cos theta 1 plus I sin theta 2. Close it. All over what? R2 into cos theta 2 plus I sin theta 2. Close it. And that is how we solve this. So what do we do now? We need to what? Multiply together by the conjugate of the denominator, the conjugate of this trigonometric identity, the trigonometric forms of complex number. So finally, what we have, that Z is equal to, let's just say R1 all over what? R2 into bracket. Now what do we have? Cos theta 1 plus I sin theta 1 all over what? Cos theta 2 plus what? I sin theta 2, all multiplied by the conjugate of the denominator, which is what? Cos what? Theta 2. This is plus, it will change to minus what? I sin theta what? 2 all over what again? Cos theta 2 minus I sin theta 2. So we'll cover it. So what do? We multiply. So this is Z equals to R1 over R2 into bracket. Now what do? The first one multiply the first, the numerator multiply the numerator, which is cos theta 1 plus I sin theta 1. Multiply it into what? Cos theta 2 minus I sin theta 2. Close it. All over. Now all over what? Cos theta 2 plus I sin theta 2. Multiply by this cos theta 2 minus I sin theta 2. Close it. So all into big brackets. Okay, let's continue. I will wipe out the answer, the questions. So now let's continue. Okay. Now let's work it out. Now what do we do here? We take it up. That Z is equal to R1 over R2 into bracket. Now what do we have? Well, we continue our multiplication. Cos theta 1 multiply by what cos theta 2 minus I sin theta 2, close it, plus I sin theta 1 into bracket the same thing, cos theta 2 minus I sin theta what 2, close it, all over the denominator, cos theta 2 into bracket cos theta 2 minus I sin theta 2, close it, plus I sin theta 2 into the same thing, cos theta 2 plus minus I sin theta 2, close it, all in a very big bracket. Okay, bracket say do me first. We start that z is equals to r1 over r2 in a very big bracket. So what do we have? Cos theta 1 times cos theta 2, we are going to have cos theta 1 cos theta 2. Cos theta 1 multiplied by this, we are going to have it as minus I cos theta 1 sin theta 2. Okay, plus what? Plus I what? Cos times sine, which is your cos theta 2 sin theta 1. So this time that is what we got here. Cos theta 2 I sin. Or if you like, you can be taking the I inside. It depends how you want it. If you like, you can take the I will look like this. Let's see it. If you like, this time this will give us this. This one, this time this will give us, I can have it as minus cos theta 1 times I times what? This I, which will give us time I sin theta 2. Okay, now let's go to this one. It will give us plus cos theta times this will give us what? Cos theta 2 times I, which is I sin theta 1, close it, plus, okay, minus I times I will give us minus I square sin theta 1 times sin theta 2 will give us sin theta 1 sin theta 2. So that is the all over. Now let's go. Cos theta 2 times cos theta 2 will give us cos square 2 theta. Okay, cos theta 2 multiplied by I sin theta 2 will give us minus cos theta 2 I sin theta 2 plus I sin theta 2 times this still give us cos theta 2 I sin theta 2 plus, is it plus or minus? Minus. I times I will give us minus I times I square minus I square sine 2 sine theta 2 times sine theta 2 will give us sine square 2 theta, and that is what to do. Okay. Finally, what do we have? We collect what? Like terms. Always recall that I square is always minus 1. Always remember that. Okay. Now from this place, z is equal to r1 over r2 into now cos theta 1 cos theta 2 minus I into bracket what we have cos theta 1 sine theta 2 plus cos theta 2 sine theta 1, close it, minus 1 times minus 1 will give us plus. So what we have here, plus sine theta 1 sine theta 2. Okay, all over. Okay, we have cos theta 2 I sine theta 2 plus minus cos theta 2 I sine theta 2 plus cos theta 2 I sine theta 2 will cancel out, which is 0. So what do we have? We have cos square theta 2 minus 1 to minus 1 will give us plus I sine what? I is okay. Will give us what? Sine square theta 2. So and that is 3. Okay. What do we do now? We need to collect what? Like terms. We need to collect like terms. Now that z is equal to r1 over r2 into what? Cos theta 1 cos theta 2 plus sine theta 1 sine theta 2 minus what? I into cos theta 1 sine theta 2 plus cos theta 2 sine theta 1, close it, all over what? Cos square theta 2 plus sine square theta 2. Okay. Are you okay? I hope you understand it. Are you okay? Okay. Let's continue up. I hope you are done. Okay. What do? We collect the one without what? This thing. I. So we have collected them. This is imaginary. This is a what? A real part. Okay. But always remember the trigonometric identity. Always remember, recall the trigonometric identity. And that is this. The trigonometric identity that says cos into theta 1 minus theta 2 is equals to cos theta 1 cos theta 1 cos theta 2. Are you with me? Plus sine theta 1 sine theta 2. And another one that says sine into theta 1 minus theta 2 equals to what? We have it as what? We have it as cos theta what 1 I sine theta 2 plus cos theta 2 sine theta 1. And that is it. So, and another thing that says that cos square theta plus sine square theta is always 1. So you need to record this at the back of your mind from trigonometric identity. From trigonometric identity, we have this. So we can replace them here in this question. We are going to replace this one with this, and replace this one with this, and replace the denominator with what? 1. Okay. Finally, we have that z is equals to what? R1 over R2 into B bracket what? Cos into theta 1 minus theta 2, close it, plus this is I. Is it plus or minus? Minus I sine what? Into theta 1 minus theta 2, close it. So all into what? Over what? Over what? 1. So what do we have? It means that z is equal to R1 over R2 into bracket what? Cos into theta 1 minus theta 2, close the bracket, minus I sine into theta 1 minus theta 2, close it, all into this, divided by what? 1, remaining this. Finally, we are going to say let R1 over R2 be what? R3. Then we have that z, final answer, is equal to R3 into bracket cos theta 1 minus theta 2, bracket close, minus I into sine into theta 1 minus theta 2, close it, all in this bracket. And that is what? The proof of what? Complex trigonometric complex function. So whenever you are proving that, you need to take your time, take it small, one after the other. Find a very big sheet, take it small, one after the other, and prove it. Always remember the trigonometric identities. All these trigonometric identities, always remember it, so that at the end you replace it. So finally, our answer is this, that has been proved. Thanks, and God bless you. Remember to subscribe to my YouTube channel, Prismatis Online Class.